The correct order of energy level in H atom. So if you are talking about H atom, it has only one electron, and that is will be in first main shell. Only one electron. Then what about the other main shells? Other main shells are still exist, but the attraction from the nucleus are very less, and there is no electrons are there. Now, when you are talking about other main shell, there is no electrons. That is, let's say there is no electrons in second main shell. Then I can say there is no electron or electron repulsion because only one electron is present. And we can say all second main shell orbitals will have same energy because there is no electron to differentiate two orbitals. So if I consider a H atom, let's say this is the nucleus. If I draw an energy diagram from the nucleus, the distance, the first main shell, 1s orbital, will have a lower energy, obviously. And the second main shell, 2s and 2p orbital. What about 2s and 2p orbital? And 2s and 2p orbital is going to have the same energy because there is no electron in the second main shell. And the 3s, 3p and 3d will have the same energy. Same goes for all. If an electron is, let's say if an electron is present here, then what you have to do, it must be present in the lower orbital. It won't be in p orbital. You have to put this p orbital higher. You have to put 2s orbital and 2p orbital. So I can say this is exciting to next shell. Kind of that time you have to use this. So always remember now. So the energy level, I can say 1s is going to be the lowest one, and that 2s will be equal to 2p, and that 3s and 3p will be equal because there is no degeneracy. Sorry, there is all degenerate orbitals, 3d, and I have 4s equal to 4p equal to 4d equal to 4f, all are equal. So our answer is going to be A. When a gold sheet is bombarded by a beam of alpha particle, only few of them get deflected whereas most go straight, because in Rutherford what we did is we take a gold foil. So this is a gold foil. I'm just bombarding it with an alpha particle. Alpha particle is nothing but the helium 2 plus ion. I know in helium I have 2 protons, 2 neutrons and 2 electrons. If you remove 2 electrons, you will get a 2 proton and 2 neutron. So overall the charge of helium 2 plus ion is 2 plus charge. Because of this, the nucleus, whatever the atoms it is meeting on the way, will have a nucleus of positive charge, and this alpha particle will get deflected due to the repulsion, proton. But the problem is, in Rutherford experiments, the 99% of all the alpha particles has crossed the gold foil without deflection, which means the meeting of this nucleus of this atom, gold foil atom, is probably very less fortune, right? Which means the nucleus is very small in volume, so it can't meet. So only a few of them which may get deflected. The exact reason for this, the nucleus has a much smaller volume than that of atom. Equal masses of two gases among N2. So I have N2, I have NO, I have O2. I have CO, I have CO2, and I have SO2. Occupies same volume at STP. So we know that all gases will occupy always same volume. Whatever the gas is, it will occupy same volume at what condition? Or you just remove this will. All gases occupy same volume will always have same, or you can say equal, number of molecules inside. So whatever the gas you take O2, you take SO2, whatever it is going to occupy the same volume if it is at same temperature. So if you measure if you count the number of molecules of O2 in one chamber and SO2 in another chamber with the same volume, the number will always become equal. The number will always be equal. So now what they are asking is equal masses. We have to find equal masses. What we know? Equal number of molecules we know. We just have to find the masses. That's all. So let's say I have a equal volume of N2 gas and it weighs, let's say it is going to weight around, it is a balance. So 1 N will weight 14 gram per mole and N2 will weight into 2. So it is going to be 28 gram. Let's say all are occupying 22.4 liter, which means 1 mole of gas will be there. Avogadro's hypothesis. Okay. Next I have another gas. 1 minute. Okay, I have another gas which is NO, which will occupy 30 gram. If I take it like 22.4 liter. If I take O2, which will occupy 32 gram again, and CO will occupy 28 grams, and CO2 will occupy 1C is 12 and O2 is 32 now. 1O is 16 gram per mole, so it is 2O, so it is going to be 32, then it is going to be 44 gram, and SO2 will be like this is 32 and this is 32, so total it was 64 gram. You can see that N2 and CO at same volume, they are going to have equal masses, right? Equal masses. So our answer is going to be D. Okay, which of the following is incorrect? We are talking about E by M ratio. For a canal race, what is canal race? It is a positively charged race, but it is not same for all. It depends on the gas you are taking out. Let's take you are getting a hydrogen gas which will have only one proton. It will give you H plus ion, which means one proton. You have a E by M ratio of a proton. E is going to be 1.6 into 10 power minus 19 and M is going to be mass of this hydrogen, right? Like not hydrogen, proton. So I can write MP. If I take helium ion, it is going to produce helium 2 plus ion where you have mass of 4U. Here it is 1U, here it is 4U, which will decreases the overall value because you have to consider two protons also. The charge is also much higher, but Still you have to divide it by 4, right, instead of 1 in H plus ion. So decreases the overall E by M ratios, even though if you are taking a nearest possible helium. So E by M ratio, overall E by M ratio will be getting lower. If you take deuterium, let's take deuterium, you have one neutron and one proton, the E remains same since the charge is only one proton, but the mass becomes double, right? So it is also going to give you less. So answer is going to be, the option is going to be correct, maximum for hydrogen, because of its lowest possible mass of proton and higher charge. And E by M ratio of cathode rays is independent of gas taken, because E by M ratio of cathode rays is nothing but the emitted from the electrode material, right? So it doesn't, we remove all the gases outside, so it is not going to depend on gas taken, it is independent, right? Yes, correct. E by M ratio will always remain same, because it is for electrons. Electron will be a single particle, single electron, that is not like two electrons, okay? And the nature of canal rays is depend on electrode material, really. For, let's say this is a canal rays, it is produced from the electron that is colliding with a gas particle, not with an electron material. It is not producing in the electron material, it is produced when a electron knock out one electron from another atom, gas atom. It depends on gas atom, not on material. So our answer, which is a wrong option, incorrect option, that is going to be your answer. So that is going to be C, and dependent gas taken, that we already discussed, right? So answer is going to be C. Identify the compound in which the total positive charge and the negative charge would be equal to 6 units. So they are asking us to find the total positive charge, either total positive charge or negative charge, because there is no word in like sum of or like addition kind of. So we have to find the total positive charge. Let's say like all are neutral, so it must be equal, total negative charge and positive charge, you don't have to worry about them. So let's see. Option A, we have a magnesium phosphate, which means I have a magnesium 2 plus ion and I have a phosphate ion. Overall the charge of phosphate ion is 3 minus. If I combine them, I'm going to get, you can use crisscross method, just put it down, Mg3 PO4 twice. So there are 3 Mg2 plus ion, which means the overall positive charge is 6 plus here. So answer is going to be A, and we'll check all the answers also, because we have all of the above also now. Aluminum carbonate I know, CO3 2 minus. Aluminum will have the charge of Al3 plus. Now what happens if this 2 comes here, this goes up, I'm getting a Al2 CO3 thrice, which means I have 2 Al3 plus ion, which is also going to be 6 plus charges. So answer is going to be D, because anyway you have found it, 2 options are right. And what is ferric chromate? Chromate ion is CrO4 2 minus, and ferric belongs to Fe3 plus, ferrous belongs to Fe2 plus. Lower oxidation state will comes with the suffix OUS, okay? So it is IC suffix, so it is a higher oxygen state. So this is going to give you Fe2CrO4 thrice, which is mean 2 Fe3 plus, which is also going to be 6 plus charge. So all of them will have 6 plus charge, so the answer is going to be D. Which of the following set of compounds cannot be used to illustrate the law of reciprocal proportion? So what is the law of reciprocal proportion? Actually, this law involves at least 3 atoms. So every option should contain only 3 atoms at least. So yes, all options are containing 3 atoms. Good. Now all these should have a 3 different compound. Let's take A. Let's see it is following the law of reciprocal proportion or not. So if I take, what are the atoms are there? Like I have nitrogen, I have hydrogen, and I have a chlorine. If I combine nitrogen and hydrogen, what do I get? I have NH3. If I combine nitrogen and chlorine, I get NCl3. Then what happens when I combine H and Cl now? So this is going to be your law of reciprocal. It always going to be the same ratio or an like a simple ratio. Let's say the ratio of H and Cl is going to be 1:1 again, HCl. Here H is 1:3, or you can say mass ratio, that will be more good. Atom ratio also fine. 1:3, 1:3. So this 3, which means 3:3. This is going to be 1:1. Your wish. So this can be used for illustrating. So they are asking cannot. So this is going to be the right one, but not right option. What about the C option? I have sulfur, I have carbon, and I have oxygen. If I combine sulfur and oxygen, I am getting SO2, carbon and sulfur, I am getting CS2, and carbon and oxygen, I am getting CO2. Yes, this can be illustrated. And option B, if I take, I have a S, I have a H, and I have a O. If I take S and O, it is given as 2 compounds here itself, and S and H, H2S, but there is no compound given for O and H bonding. So this is going to be our answer, which means real answer, right? Because it cannot be used to illustrate the law of reciprocal proportion. Let's talk about H2S, SO2 and H2O. Same SO and H. This is SO2, this is H2S, and this is H2O. Anyway, this is going to be like we can use to explain it. So the real answer is going to be B. On a Fahrenheit scale of temperature, the freezing point of water is marked as 32°F. So what they are saying in this question is, I have a scale which is nothing but the Fahrenheit scale, where the freezing point of water is marked as 32°F, and I have a boiling point of water which is marked at 212°F, and I have a degrees Celsius scale where 0 degree, as you all know already, and 100 degree as boiling point of water. Now you have to convert the 104°F into Celsius scale. Damn good if you know the conversion already. But using the given data, how do you convert this? It is a lot more easier. Let's see how it is done. The first thing you should know, water is the reference for all the scales, and using this formula you are going to convert any scale into any other scale values. So it should be like scale minus the freezing point of water in that scale divided by the BP of water, which is nothing but boiling point of water, minus the freezing point of water again. If you know this, all scale follow this rule. So it should be equal, let's say degree Fahrenheit to degree Celsius, right? So degree Fahrenheit minus, I have a freezing point of water is 32°F divided by boiling point of water is 212°F. Just remove the Fahrenheit better to make it more clear. Minus again 32 equals, in degree Celsius it should be freezing point of water is 0 divided by 100 boiling point of water in degree Celsius minus 0 in it. So in degree Fahrenheit, minus 32 divided by 212 minus 32 is, so 180 will be equal to degree Celsius by 100. Okay. Now you put the scale. Degree Fahrenheit is given as 104 degree Fahrenheit, right? Just put it here. 104 minus 32 divided by 180 is equal to degree Celsius by 100. So 104 minus 32, it was 72, and if you know, you can cancel these two with the table of 20, I think. So it will come under 5, this will come under 5, 9, right? So 72 divided by 9 equal to degree Celsius divided by 5. Okay, 9 and 72 I think you can cancel. So it will come under 18, 8 I mean. So degree Celsius will be equal to 8 5 are 40. So our answer was going to be 40 degrees Celsius, which is nothing but option B. Okay, for the hydrogen atom, the energy required for the removal of electron from various subshell is given us. So I have hydrogen atoms, not various subshell, it is 3s, all are belongs to third main shell, right? So what happens to third main shell whenever there is a hydrogen atom with one electron in it? Let's say it is in the ground state and it has an electron at let's see, this is going to be the third main shell. Let's talk about this. So this is a nucleus, right? This is a nucleus, right? So the energy will increase upon going from the nucleus. So this is a nucleus. So first main shell will have an electron, so this will have lower energy, and the second main shell doesn't have an electron. So there will be there will always be degeneracy, which means all orbitals will have same energy because there is no electron-electron repulsion. If this electron will excited to here second main shell, then electron will think of staying at lower energy level in like s orbital or in p orbital, but still it is in first main shell, so there is no point of saying difference in energy in second main shell. Second main shell will all wholly have like same energy, right? And the third main shell will have the same thing, like same energy. So all 3s, 3p and 3d will have same energy. Directly we can put C option. Which of the following species is or isoelectronic with neon? So neon, what is isoelectronic? Iso means, always remember, it is refers to same, and electronic, it is nothing but electrons. Which of the species having same electron as neon has? Neon have 10 electron, right, in its neutral form, and I have nitrogen which have 7 electrons in its neutral form, but N3 minus, which means I added 3 electrons more to nitrogen, so it will have 10 electrons, right? So neon and nitrogen 3 minus, N3 minus is going to have the same electron, same number of electron. I can say both of them are isoelectronic to each other, right? So first option is right, so I can eliminate A and B. Let's talk about K. Okay, K plus, what is K plus? K is going to have 19 electron. If I take K is going to have 19 electron. If I take 1 electron out, what happens to the K? 1 electron will be less, which means 18 electron, which is a configuration of argon, not neon. So I can eliminate 2. So answer is going to be 3. I mean D. Let's check third one. Magnesium will have 12 electrons, and if I remove 2 electrons, it is going to have 10 electrons. So it is going to isoelectronic with neon. And calcium will have 20 electrons. If I remove it, it will have 2 electron. If I remove, it will have 18 electron, which is isoelectronic with argon again. So I can say calcium and potassium will be isoelectronic with, I can say directly here, these two are going to be isoelectronic with argon, whereas nitrogen ion and magnesium ion N3 minus and Mg2 plus will be isoelectronic with neon. So answer is going to be D. The magnitude of electrostatic force between two tiny spherical balls carrying charge Q1 and Q2 separated by a distance R in a free space. Okay. I have two spherical balls. So I have two spherical balls which is separated by a distance, which is Q1 and this is Q2. And this is going to have the force that we already know, the force of attraction or repulsion between two charged particles is going to given by K, which is a constant, is into Q1 Q2 by R square of the distance, right? Inversely proportional to. Okay, now what is the distance? Let's see. K, we already know the K is going to be equal to 9 into 10 power 9. And the two tiny spherical balls of carbon, okay, both are made of carbon, which is 1 gram and 1 gram carbon, are kept 1 centimeter apart. So the distance between two spherical balls is 1 centimeter, or you can convert into meter better. For force, they will give in Newton, no? So better you convert this into 10 power minus 2 meter. You can write it. The two spherical sphere has equal and opposite charge, so I can rough this Q1 Q2, that is equal and opposite. Let's say Q1 Q is minus. The magnitude of, only they are asking about the magnitude, so I can use the magnitude of this force is given as 1 into minus 5 is equal to minus 9. I don't have to consider because magnitude anyway, not about the direction. So 9 into 10 power 9, and Q we have to find anyway. The Q, I can put Q square because Q1 and Q2 are equal, and R is 10 power minus 2, and it is square. And what they are asking to find is the two spheres. Okay, fine. Between the two charged sphere, then the ratio of number of excess electron. Okay, we are going to consider the excess electron, which means the overall charge that responsible, how many electrons are producing Q amount of charge. That is the excess electron, right? Using the Q charge, we can find the excess electron. And the total number of atoms in the negatively charged okay, negatively charged. Done. So one of them is negatively charged. You have to calculate this. First, calculate the charge. What is Q? Q is going to be, Q square is going to be, you take this 9 here, it will become 1 by 9. If you take this 10 power 9 here, it will come down, and already it has 10 power minus 5, and if you take this 10 power minus 4 up, you will get this. Okay. Now if this goes up, it will become 10 power minus 9 again. I can rough this so that the final value is 1 by 9 into 10 power minus 18 total. Q square is equal to, then what about Q? Q is equal to square root of 1 by 9 into 10 power minus 18, right? So it is, if you take the square out, you will get 1 by 3 into 10 power minus 9, right? So this is going to be our Q. And what about the charge? This is the charge of, I can say charge of n amount of electron. I know the charge of one electron is going to be 1.6 into 10 power minus 19 coulomb. So this is, so how do I like calculate number of electrons? So the number of electron I can calculate by the overall charge that produced by n number of electrons divided by the each electron's charge, which is nothing but 1.8 into 10 power minus 19. So 1 by 3 into 16, it is 4.8, and if I take this up, it will become 10 power plus 10, right? So this is going to be the number of electrons in one single sphere, because you are used only Q, right? Not Q square, because Q square will gives you 2 spheres charge. Now, we are going to convert that. What about 1 gram of carbon? So 1 gram of carbon, I know like 12 gram of carbon equals 1 mole, or it equals any of atoms of carbon. Then 1 gram of carbon will be equal to 1 by 2 mole, or 1 by 12 mole, or 1 by 12 into 6.023 into 10 power minus, plus 23 atoms of carbon. Now I found it. And now what is the ratio? Total number of atoms. So first one is excess electron, that I have to find the number of electrons in that sphere divided by number of electrons in the carbon sphere. 1 gram of carbon atom, not number of electrons, it is the number of carbon atoms, right? Okay, number of carbon atoms I can directly put. So Ne is going to be, we already found it here, right? So 1 by 4.8 into 10 power 10 divided by 1 by 12 into 6.023 into 10 power 23. Take this 12 up, so that 12 by 4.8 into 6.023 into 10 power, if this goes up, it will become minus, so we will get 13, minus 13. What is 12 by 4.8? That you already know, right? 12 by 4.8, like 12th table, right? 1 and 12, 24, 4 times, so 0.4 you can write. Yeah, right. Or you can write like 1 by 0.5, or you can write like 2.5 quarter amount, right? Like now 2.5 divided by 6.023 into 10 power minus 13. If you divide this, you will get around 0.415 into 10 power minus 13. So 4.15 into 10 power minus 14 I can write. So this is going to be your answer. Is there any option support this? Yes, we have. The only thing, if you find 10 power minus 13, 14, you can answer this question directly. If you want to find exact answer, you have to solve it. To manage the time, you can find the 10 power exponent alone. That is it. That itself fine. So the answer is going to be A. Which among the following is true? Air is a bad conductor or good conductor of heat? Obviously, air is a bad conductor of heat, that we already know. So I can eliminate B and D option directly, because air is not a good conductor of heat. And the expansion, thermal expansion, which means I'm heating a solid and I'm heating a gas, which will expand more. Obviously, gas will expand more, right? Gas will expand more. So gas expansion will be more, or you can say solid expansion will be less than that of gas. So answer is going to be C, direct answer. Arrange the following changes of energy during following phase transition in a proper order. So what they have given is, I have an ice cube which is at 0 degrees Celsius. First it has to melt, right? It has to break all the bonds, so that I can say its potential energy is increasing, which means it is absorbing energy to break all of its bond to become a liquid, which is also going to be at 0 degrees Celsius, because only the potential energy is going to release, and there is no increase in kinetic energy. If there is an increase in kinetic energy, temperature will change, because temperature is a measure of average kinetic energy of a molecule. So after that, what happens if I give temperature extra, like the whatever the temperature that is absorbing to increase the potential energy in a phase change, that temperature is called, that heat is called latent heat. And whatever the heat that is absorbed to change the temperature, which means to change the average kinetic energy, that is called specific heat. Specific heat measured per temperature rise. So how much the temperature is raised? 50 degrees. So 50 degree water is going to stay at the same water. So here what happens? Here the kinetic energy will also be increasing. The potential energy is also increased, and the kinetic energy will also increase. Because of that, the temperature is changed. And now again I am going to bring it to 0 degree water. And now what happens again? Potential energy will decrease and the kinetic energy will decrease, just the reverse process. And I'm going to make it as a solid. Then the kinetic energy will remain same, but the potential energy will decrease, because to make a bond it has to release energy, which means the system energy is going to decrease. So which order follows this? First, the potential energy has to increase. The potential energy has to increase. And the increase in potential energy, kinetic energy remains constant is option 1. And the potential energy and kinetic energy increases option 3. And this is 1, this is 2, and this is 3, this is 4, right? The answer is going to be 1, 3, 4, 2. So option C is going to be your answer. There are 3 closed containers in which equal moles of gas is filled. If the container are placed at the same temperature, then which of the following is correct? So they are asking about the pressure, that's all, right? So each of them will have almost same volume. No, they are not going to have the same volume because of their different shapes. Let's see whether they have same volume or different volume. The first one, which is a cube, which has a side of length 5 centimeters. So for a cube, which is like this, right? This is a cube. The volume of cube is measured as a cube. So 5 into 5 into 5, which is going to give you 125 centimeter cube. And the cube of cylinder, so this is a cylinder, let's say this cylinder, I can say volume is given by pi r square h. So I need both are 5 centimeters, so I can directly do it. Pi into r is 5 into 5 into 5, again 125 pi, which means it is going to be 125 into 3.14. And then you have a sphere. It is not a circle, it is a sphere. Sphere. What is the volume of sphere? It is 4 by 3 pi r cube. So you will get 4 by 3, which is going to be 1 point something. So or you can just put it pi into r cube, again 5 cube, it is going to give you 25. So which value is greater? First of all, this volume is going to be greater of all, right? So volume of sphere is going to be greater of all, and I have a volume of cylinder is going to be lesser than sphere but greater than cube, because cube is going to have the very less volume. What about the pressure? They all have the same number of molecules, which means if greater the volume, those molecules will stay little bit pressureless, because there is no it has more space to roam around, right? But if it is having a lesser volume, then there is a problem. Like small space to occupy, it has to exert more pressure. Small surface area, small volume, right? So what is the relationship between a pressure and a volume? I have a two container, one is small, one is big. So volume big means more place to roam around and the pressure will be less. Or you can talk about collisions also. Lesser surface area, more the collisions. So more the volume is less, more the pressure. So for pressure, the order of this is going to be the reverse. Cube is going to have more pressure than, sorry, not V, it is pressure, right? So pressure, cube is going to have more, and then cylinder, and then the sphere is going to have less. So pressure in one cube, which is going to be the maximum one. The order of vapor pressure of four liquids. So the four liquids order is given as P, R, Q, and S. So which has a maximum tendency to sublime. What is sublime? It is the direct conversion of solid to gas. So which substance can sublime faster? Which will have a very low boiling point, I can say. And what is the relationship between a boiling point and a vapor pressure? As we discussed in previous question, boiling point is inversely proportional to vapor pressure, which means if I have two solution, both will have different boiling point. Let's say it has a boiling point of 100 degrees Celsius. This one is having a boiling point of 150 degrees Celsius. So one will have more vapors at certain temperature and one will have less vapors. Let's say I'm maintaining it at like 90 degree, 99 degree. So boiling point which is having a lower will have more vapors, which will have more vapor pressure because of more vapors exerting pressure on the surface. And this liquid will have less vapors which will exert pressure, less pressure. So vapor pressure is lower, higher. For what? Boiling point is more. So boiling point and vapor pressure are inversely proportional to, and which will sublime faster, which will have lower boiling point, and this will have more vapor pressure, which means S is going to sublime faster. So answer is going to be D. A boy gifted a diamond ring to his mother on her wedding anniversary. If this diamond ring contains 3-carat diamond, then the number of carbon atoms. We know that diamond. What is the diamond? Diamond is a allotrope of carbon, right? So I have 3-carat diamond, which will weight. I know 1 carat is 200 mg. That is given in the question. So 3-carat will weight 3 into 200 mg. Mg is milligram. 1 milligram is equal to 10 power minus 3 gram. So I can expand this milligram into gram. So 3 into 200 into 10 power minus 3 grams. So if you do it 3 into 0.2 gram, so it is 0.6 gram. So I have 0.6 gram of carbon atoms in a diamond. And I know one thing, or anyway, we are going to calculate the moles. So what is a mole? So 1 mole is equal to 12 gram of carbon. That I know. So 1 gram of carbon will weight 0. Or 1 by 12 mole, right? Then what about 0.6 gram? So I can multiply both sides by 0.6. So I will get this value. Or if you want really simple without doing this, you can go for moles is equal to given mass by molar mass. Directly you can do it, right? So So given mass is 0.6 gram divided by the molar mass is 12 for carbon. So gram will get cancelled, you will get the mole. So in both the cases, answer is going to be 0.05 mole. So the answer is going to be A. Select the correct statement regarding an element having 2 electrons in K shell, 8 electrons in L shell and 10 electrons in M shell and then 2 electrons in N shell. What does it mean this? So let's count the total number of electrons that you can do it, right? So this is an element, let's take that element is neutral. So it will have 2, 8, total 10, 20, 22 electrons in there. So 22 electrons, it is neutral. So it is going to contain same number of protons as well. So it is 22 protons. Now arrange the electrons in their increasing order, or you can find the electronic configuration of that element. So it is going to be like, maybe I can draw a shell like this. K, L, M and one more, right? So in first shell, this electron is going to, this is a nucleus which is positively charged because of proton and neutron also there. So in first cell I have 2 electrons, in second cell I have how many? 10 electrons, sorry 8 electrons, right? Yeah, 8 electrons. Third shell I have 10 and the fourth cell I have 2, N, like K, L, M, N. Now how this is really true? Let's check its electronic configuration. 1s, 2s, 2p. In third main shell I have 3s, 3p and 3d. In fourth main shell I have 4s. But the filling of electrons in these orbitals will be different. It follows by half-bar rule. What is half-bar rule? It is n plus L rule. So n is nothing but the principal quantum number, whereas SPDF will have the L value of 0, 1, 2, 3. So according to this, if you go for this on S, so S orbital will have the L value of 0. So n value is 1. This is 1 first main shell. So n value is 1, 2, 3, 4. And this P will have the value of L1. So it is 2, 2 plus 1, 3, 4. And this D will have 2. So this is going to be 5. So how will you fill this actually? So you will fill 1 electron in 1s2 and the second electron in 2s2 and the third electron in 2p, and all the electron you can fill it until you are getting 22. And the fourth main shell you have to fill 4s first because its energy is less compared to 3d. So you have to fill 4s first. 3s2, 3p6, 4s2, 3d2. Now you can see in first main shell only 2 electrons. In second main shell 8 electrons. In third main shell you have 10 electrons. And the fourth main shell you have 2 electrons. Now what about this third main shell? D orbital, right? I know D orbital will have degeneracy of 5. So in this orbital, these 2 electrons are there. All other orbitals are filled. Filled means all other orbitals are having completely filled and completely paired electrons. This d orbital will have 2 unpaired electrons. So it contains 2 unpaired electrons. Yes, it is going to contain 2 unpaired electrons, and thus 2 electrons will be in D. It is not 1, it is 2. It contains 10 p electron really. Let's check. So it has p here, so it is totally 12. So it is also wrong. It is a non-metal. No. Why? The last orbital is s orbital. For a non-metal, mostly it should be p orbital. So it is not a non-metal. Whenever it ends with D block, it is going to be a transition metal. A mixture of three liquids X, Y and Z when subjected to fractional distillation. The order in which the vapors condense back to liquid state in fractional tower is. They have given the order that Y is going to condense first and then X, then Z. So I can consider this is a pot, okay. This is where the fractional column is. And I have, let's say, 3 rows. And I have a Y here because it condenses first in the lower here itself. And the X evaporated quite more and condensed on X, I mean middle portion, and the Z is on the top. Now what is happening here? Which will condense first? That you have to know. Now if I take hot burnt one and I'm just heating the solution which contains X, Y and Z, and you know that the temperature will be more on closer to it and less on the top side. Let's say this is going to be 60, this is going to be 80, and sorry, let's say the first one is going to be 100, the second one is going to be 80, and the third one is going to be 60. So nearer will be quite hotter, the temperature will be higher, and the farer will be lower. So let's say these compounds X, Y and Z, they are going to condense at the temperature mentioned here. So Y is getting condensed on 100 degrees Celsius, will tilts this about the condensation point, or I can say the boiling point. So Y is going to have the boiling point higher, which means it will boil at 100 degrees Celsius, or it will condense at 100 degrees Celsius. And 80 degrees Celsius, Y will be in solid because it will boil at 100 degrees Celsius only. So more Y will be here, and then 80, and then 60. So I can say the boiling point lower will condense little bit late and less, while boiling point more will condense faster. So the boiling point order of these is going to be Y is going to have more boiling point than X than Z. Now what is the relationship between the boiling point and the vapor pressure? Let's take a liquid. I am heating it 100 degrees Celsius, and I am taking one more liquid which is also I am heating 100 degrees Celsius. One will have more vapors, one will have less vapors. Who will have more vapors? The boiling point, which is lower, will have more vapors, which will exert more pressure on the surface, and the vapor pressure is going to be higher. So I can say from this, boiling point and vapor pressure are inversely proportional, right? Then the vapor pressure order will be Y is going to be less, and then X, then Z. So Y, X and Z is going to be your answer. The answer is going to be B. Wet clothes is placed on a forehead of a person. So I have a person. So he's that person. He is having a very feverish, he is feeling. So which means his temperature is so high. So I'm going to place a wet cloth. So what is mean by wet cloth? It is wet cloth has a lot of water molecules. What happens to this guy if I place a wet cloth? This water molecule that is present on this cloth is going to absorb the heat. This is the skin of, let's say this is the skin of this boy. So this skin is emitting a lot of heat, which means higher temperature. So this water molecule will absorb that heat and evaporate using, I can say, to evaporate water needs latent heat, right? So this latent heat is going to absorbed by this wet cloth water molecules, so that the skin temperature or the forehead temperature or the body temperature will be lowered, because the temperature is get lowered by emitting the heat, and the heat is absorbed by the water molecule, which cause the decrease in temperature in this skin or body. So I can say evaporation. Due to that evaporation of water molecule causes cooling. Yes, correct. So Vasasan and reason, or both are correct, right? An element X has two natural isotopes. So I have two natural isotopes. One is having an atomic mass of 10.013 U. U is unified mass. And I have another isotope which has a weight of 11.009 U, just here and here. The relative abundance of this isotope in nature, which means in this world, in this universe, if I take 100 gram of something, so I would find the element which is 10, which is having atomic mass of 10.013. I will find it 19.8% gram in grams, you can say. And I have 80.2% of this one, this isotope. Okay. Now, on the basis of these data, average atomic mass, so I have to calculate the average. So I will give you one detailed explanation about this. Let's say you are in a class of 100 people. Okay. Out of this 100 people, you have 90 people or 90 marks 80 people got in an exam, and remaining 20 people got 100 marks. Now you have to calculate the class average. How do you do it? You have to find all the marks, you have to add all the marks, right? So you have to add all the 80, 90 marks, right? Plus all the 20, 100 marks, right? And you have to divide it by total number of students, that is nothing but 100. I can make it quite short here. So I can write it like 80 into 90, because you are adding 90 80 times. So next I can do it 20 into 100 divided by 100. Even I can do one more thing. I can separate these two into 100 100. I mean two fractions. 80 into 90 by 100 plus 20 into or 100 into 20 by 100. So these things here 80 is better, and here it is 90. Now you see, these two are the percentage that 80 people, or I can say 0.8 fraction, and this is 0.2 fraction of the whole people got. The same thing I can do with here. So what I have to do, this is the real marks, so this is the real atomic unit, and how many of them? 19.8 percentage, so that I have to write it in a by 100 fraction, right? So divided by 100 plus 11.009 into 80.2 divided by 100. That's all. So this is going to give you the average atomic mass. So what is the average atomic mass here? So if you calculate this, you will get the answer as 10.812 U. So this is going to be your average atomic mass. So the correct answer is going to be D. See the figure. The valve X and Y are open simultaneously. Okay, I have two things. One is this gas and one is this gas. Let's talk about the weight of those gas. H is going to have the weight of 1 gram per mole and Cl is going to have the weight of 35.5 gram per mole. The total weight of this gas is going to be 36.5 gram per mole of gas. And I have a NH3. So NH3 is going to have 17 gram per mole because hydrogen is 3 and N is 14. 14 plus 3 is going to be 17, right? Yeah. Now who is bigger mass? They have more mass. So it will move slower. So lower, I can say lower rate of diffusion because of its mass. And what happens when I open it? It won't meet at the, whenever they are meeting, they are going to form a NH4Cl. So they are not going to meet at the center anyway. One is slow, one is faster. And who is faster first of all? Like this one is faster, so it will cross the B first. It will slower, it won't cross the C at much as, right? It will cross the A also faster. So they will meet at the point in between A and Y, right? So they will meet at C most probably. So answer is going to be C.